Hello everyone, it's Wilson here. Today we are going to talk about how to find the length of this curve from x equals 1 to x equals 2. So what do we do first? We are going to just recall the formula for finding the length of a curve, right? So let's just recall that first. Okay, so we are going to just recall that, and then I'm just going to put it here. So the length of the curve is actually given by this formula right here, which is from a to b, and then the square root. Okay, and then we have the square root of what? The square root of 1 plus dy over dx. So that's the derivative of y with respect to x, and then you square that, and then you add 1 to it, and then you take the square root of that, and then, yeah, so there is a dx right here. So this is what we will need to be using to find the length of the curve. Okay, so that means the first thing is what? The first thing is to find the dy over dx because we need that derivative to plug into the formula. Okay, so let's rewrite this function first. We have y is equal to 1 over 3. I'm just going to, instead of leaving it as a quotient, I want to write it as a product. So I have 1 over 3 times x cubed, and then plus. Now, because I'm going to take the derivative, so I want to write that as also a product, right? So we are going to have 1 over 4 times x to the negative 1. Okay, so far so good. So now we are going to take the derivative. So to take the derivative, we are going to be getting, okay, so dy over dx is going to be equal to the 1/3 we don't need to worry about it, and then we bring the 3 down, so that will be 3 times the 1/3, right? So we have 1 over 3 times the 3x squared, okay, and then now plus 1 over 4, and then what we are going to do is to bring this negative 1 down and then subtract 1 from it. So we are going to be getting times negative 1 x to the minus 2. So if you simplify this a little bit, right, you can cancel those things out, and then you are going to be getting x squared and then minus 1 over 4x to the negative 2. The reason for why I have a minus sign here is really because there was a plus, there was a minus here. We multiply them together, you get the negative 1 over 4. Is that okay? So that's our dy over dx. So now we are ready to find the length of the curve. So we are going to set up the integral as the integral from 1 to 2 because those are the limits for x, right? So you just put 1 for the lower limit and then the 2 for the upper limit. And then now we have the square root, okay, the square root of 1 plus. Now we want to square this and then we put it here. So we are going to be getting x squared minus 1 over 4 and then x to the negative 2, right? And then you square that, and then all that is being put under the square root. And then you have the dx. So basically, we have the integral set up already. So now the next step is to do what? The next step is to integrate. Now, as you can see, the square root actually makes it hard to do the integration, right? And so at this point, it doesn't seem like there is anything that we can do, right? It feels like there is nothing that we can do. So, but of course, we can do something here, which is to expand this square right here. So let's try that. So if we are doing the expanding, the square, then we are going to be getting 1 plus. Okay, so how do you expand this one? We can write 2 copies and then we multiply it out, right? We FOIL, or we can simply just use the different formula for that. So let me just move this one. I think we need more space for this problem. So let me just recall something else right here. So I want to recall. I want to recall this. So let's say we have a plus b, okay? Actually, in this case, it would be a minus b squared because of the minus sign in between. So that would be equal to, it would be a squared, so that's the first term square, and then minus the 2 times the a times the b, okay? And then plus the b squared. Yeah, so if you look at this, then that's a squared, right? The first term square, and then the minus 2ab, which is basically the first term times the second term, including minus sign, and then you double it. So that's why we have the 2 here, and then you add the square, the second term, so you get the b square. Okay, so we're going to do the same thing here. Then we are going to square the first term, which will give us what? We are going to be getting x to the 4th, right? Because you're squaring the x squared. And then now you want to multiply the first term, the second term, and then you double it, right? So you are going to get minus and then the 2. Okay, so the first term would be x squared. Okay, second term would be 1 over 4. Now I already put the minus sign in the front, so I don't need to put the minus sign right here. Then I get x to the negative 2. Okay, and then the last term square, you square the last term, you square the second term, you square the 1 over 4, you are going to get 1 over 16. You square the x to the negative 2, you get x to the negative 4. And then all that is under the square root. Okay, and it would be a good idea right now to do some simplifying first, right? So you can see the 2 and the 1 over 4. You can cancel the 2 and then the 4, so you get a 2 here. And then what about the other stuff? The other stuff, we can also cancel the x squared and then the x to the negative 2. So now you basically will only have a 1/2 right here with the minus sign, so negative 1/2. Okay, so let's just write that down. So we have integral of from 1 to 2, and then the square root of 1 plus x to the 4th, and then minus 1 over 2, okay? And then plus 1 over 16, x to the negative 4. Okay, so just keep in mind here, there's one thing that's really important to remember, is that, do you see that this expression right here, I didn't touch the 1, so the 1 has been there the whole time. And I have this expression right here. Let me just highlight this expression right here. Do you see that it actually comes from expanding this, right? I did the simplifying, but I didn't do anything to the 1. So basically this expression that I'm highlighting right here comes from this binomial square, okay? So now what happens is that we are going to simplify even further, because right now we can actually put the 1 and then we can combine the 1 and the negative 1/2, which will now give us the expression x to the 4th, and then you get plus 1/2, and then plus 1 over 16 x to the negative 4. Then there is a dx. Remember that I will cover that. Now, I just want to highlight another expression right here. Do you see that this expression right here is really similar to that expression? The only difference is that that one has a negative 1/2 in the middle, and then this one has a positive 1/2 in the middle. So now how do we compare them? If we go here and then we call another one, let's just recall another one right here. So if we have a plus b, and then square, and that's actually equal to the first term square plus 2 times the first term times the second term plus the b square. Do you see the difference between those two? It's really just that sign that's different. Okay, and then we are actually getting the same thing right here. And remember that this expression, this green expression right here, comes from this x squared minus 1 over 4x to the negative 2 quantity square. So if those two are equivalent, then we can say that this can also be factored into this form. Now, it's not the minus sign between anymore, it would be the plus sign in there. Is that okay? So now we can factor this. And when we factor this, it would be extremely similar to that one, except that the sign in the middle would be plus. Okay, so now let's just rewrite that, and we are getting 1 to 2, and then the square root of x squared. Okay, so I'm just going to use that same color that we have from before. So it will be x squared, right? So it's the same term, also the same second term, except that the sign will be opposite. So it will be plus 1 over 4 x to the negative 2. So that's this one here. Oh, I forgot the square, right? There is a square in there. Now, but because the 1 is not there anymore, we can actually just cancel out the square and the square root. When you cancel them, you're going to be getting a pair absolute value right here, but because x squared is positive, 1 over 4 x to the negative second is also positive. When you're adding two positive numbers together, you are always going to get a positive number. So in that case, we don't really need to worry about the absolute value anymore. So we are going to get the integral as just that expression. So x squared plus 1 over 4 x to the negative 2. And then now we can integrate term by term, right? Those are just reversing the power rules. So let's do the integration right here. We are going to be getting x to the third, 1 over 3, and then plus 1 over 4. And then we get x to the minus 1. You are going to add 1 to it, and then you multiply by negative 1 also. And then evaluate it from 1 to 2. Okay, so let's continue with the calculation here. We are going to be getting, let's just plug the 2 in there. If you plug the 2 in here first using fundamental theorem of calculus, then you get 2 cubed, which is 8 over 3. So you are going to get 8 over 3. And then minus. Now, why do we get minus? It's really because it's negative 1 times 1 over 4. So minus 1 over 4, you plug the 2 in there, you get 1 half, right? 1 half times 1 over 4 is 1 over 8. And then minus. Now, you plug the 1 in there, you get 1 over 3. And then minus, plug the 1 in there, you get 1 over 4. Okay, so get the common denominator. Well, we can just combine those ones with the same denominator first. So we are going to get 7 over 3 right here, right? And then, so you take the negative 1 over 8, minus minus plus 1 over 4, which will give you plus 1 over 8. And then here we get the common denominator, so I'm just going to do it faster now, times 8, so you get 56, plus this one also times 3, so you get 3 over 24. So altogether, you get 59 over 24. And that would be your final answer. Right? The tricky step right here for the integration, it's really coming from integrating this thing right here. And we actually need to recognize that this would be a perfect square if you factor it, and so that we can write it in the square form so that the square and the square root can get canceled, so that you don't have to deal with the square root anymore. In general, the square root will make the calculation a lot more difficult, right? If you have a square root there. Okay, so that's it for this. To help me make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily.